How do you actually know if a machine learning model is any good? Most people just check one number, the accuracy score. If it's high, they relax. The model works, but the score can quietly lie to you. So today I want you to walk through the two ways it does that and how we can catch both. Once you see this, a high score will never fool you again. So the first way is the simplest one. Picture a student a night before an exam. You hand them a question paper with all the answers already filled in. Of course, they are going to ace the exam in the next day. But did they actually learn anything? You have no idea because you only tested them on what they have already seen. And the model is no different. Train it on some data and then test it on that same data, and of course, it scores high. It's just repeating answer it already knows. So we never do that. Before training even begins, we split the data in three. The number one is training set, where the model learns, the validation set, where we fine tune it, and the test set, which we lock away, don't touch until very end. That's it, the final exam. No question it has genuinely ever seen. And that handles the first lie. Now the score actually means something. But the second, sneak your lie. And it shows up even when you have already done everything right. Let me give you a real example. Say you build a model to catch fraud. In the real world, fraud is very rare. Out of every 100 transactions, 99 are normal and just one is fraud. Now, picture a lazy model that labels every transaction as normal. It would be right 99 times out of 100. 99% accuracy looks brilliant, but it caught zero fraud unless at the only job it had. So the score isn't lying here, it's just measuring the wrong thing. So when the data is this lopsided, we stop trusting accuracy and read two smarter number inside. Precision asks when the model cries fraud and how often it's actually right. And recall asks how all of the real fraud out there, how much did it actually catch? Those two tell you the truth that accuracy was hiding. So let's bring it together. To really trust a model, you check two things: that it's judged on the data it has never seen, and that you are measuring the right thing, especially when the data is lopsided, or we can call it as imbalanced. But I will leave you with something odd. Sometimes a model passes both these tests perfectly and still falls apart the moment it meets the real world. That's a problem called overfitting, and that's exactly where we go next. I hope it's clear to you all, and I will see you up ahead in the next one.